Hello class. Today we are looking at section 6.5, solving equations that contain rational expressions. Turn to page 407. It talks about extraneous solutions. It says such false solutions are called extraneous solutions. So they are false solutions. When we look at the examples, we will talk more about that definition, extraneous solution. Now turn to page 410 and look at number 25. The direction says solve each equation and check the solution. So on number 25, you have to apply some of the information that we learned back in section 6.4. We talked about condensing those complex fractions. So you're going to look at this in the same way, except it's slightly different, but you still need to be able to identify what is the LCD. And we'll see what the purpose of 6.4 was and how does it tie into section 6.5. So let's look at number 25. So 25 has x over x plus 2 plus 3 equals 2x over x plus 2. Now look at the problem. What is your least common denominator? I see a denominator of x plus 2 and a denominator of x plus 2 again. 3 is understood to be over 1, so we don't have to include that 1 because we know it's understood to be a 1 there. So my least common denominator is what's different in your denominator. The only thing is different is 1 and x plus 2. Don't need to write the 1. So my LCD is x plus 2. I'm going to write each part and multiply it by x plus 2. Very similar to what we saw on section 6.4. What happens next? We start canceling out. When you cancel out, it needs to be one at the top, one at the bottom. If it's top bottom, you can cancel. If it's not top bottom, don't cancel. So if you notice here, I didn't cancel because it was nothing in my denominator to cancel out with the x plus 2. Clean up the problem. I am left with x plus sign. 3 times x is 3x. 3 times 2 is plus 6 equals, what is left over is 2x. We're going to now solve for x. So I want to just get x by itself. I can do a lot of things. I can move my x's to the right or move my x's to the left. So however you want to solve x, do it. 1x plus 3x is 4x plus 6 equal 2x. I'm going to move the 4x over to the right. It doesn't matter though how you move it. It's still going to come out correct. If I move 2x to the left, it's going to still give me the same answer. So I have 6 equal 2x minus 4x. So 6 equals negative 2x. Divide both sides by negative 2. My answer is going to be x equal negative 2 goes into 6, negative 3 times. So my answer is x equal negative 3. The question does say check it. The best way to check this is we talked about back in 6.1. We talked about when answers are undefined. An answer is undefined when it's a number divided by 0. If I plug negative 3 back in, my denominator only, does it equal 0? Well, 2 minus 3 is negative 1, not 0. 2 minus negative 3 is negative 1, not 0. So if I check my denominators, negative 3 is okay. my denominator can't be negative 2 because 2 minus 2 is 0. But that wasn't an answer, so this answer will check out okay. Let's try another one. Number 31. Now on 31, we're going to see a problem. And we're going to find out what extraneous solutions mean once we look at 31. So 31, I have a squared over a plus 2 minus 4 times a plus 2 equals a. Now, before I do my math, look at your denominator. What can a not be? A cannot be negative 2. Because if I say 2 minus 2, it equals 0. So I'm going to do a little side note. I know that a cannot equal negative 2. I don't want it to equal negative 2. I don't want a to equal negative 2 because if it equals negative 2, that means that it is undefined at negative 2. And that answer, if I get an answer that says negative 2, that is where my extraneous solution will be. So let's work it out and see if we get an answer that says a equals negative 2. If it does, we have to throw that answer out. We can't use it. So let's find out least common denominator. My LCD is a plus 2. Every part, I'm going to multiply it to a plus 2. Let's do the math. These cancel to 1. A plus 2 here cancel to 1 also. Write down what is left over. In the first section, I see a squared. In my next section, I see minus 4 equals a times a is a squared. Plus sign, a times 2 is 2a. Now you tell me how many answers am I going to have for a? So this part can be a little tricky. How many answers am I going to have for a? I see 2, but when I subtract a squared, what happens to the a squares? They cancel out. They go to 0. They equal 0. I'm left with negative 4 equals 2a. Divide both sides by 2. So a equals negative 2. But what did we say earlier? If I plug in negative 2 for a, in my denominator only, don't worry about the numerator because we're checking for extraneous solutions. If I plug in negative 2 for a, 2 minus 2 in my denominator equals 0. A cannot equal negative 2. A can be any number I want except negative 2 because it's a problem there. So do we have an answer? We don't have an answer for 31. The way you write that is you use this notation here. That is called a null set. N-U-L-L. That's a null set. That means I don't have an answer for A. And we're going to write down that negative 2 is extraneous. My null set, or it can be also said an empty set. E-M-P-T-Y. It's an empty set or a null set. This is saying I have no answer that I can use for A because we saw for A it was negative 2. I can't use negative 2 because it will give me a 0 in my denominator. So I'm going to say negative 2 is extraneous. That's a false solution. I can't use negative 2. So we say we have an empty set. There's nothing there. Let's try another example of that. So very important that you write down your vocabulary. We talked about extraneous solutions. Those are false solutions. So if I get an answer and I plug that answer back into my denominator and my denominator equals 0, I have to throw that answer out. I can't use it. A null set or empty set is a situation where none of my answers work. So if none of the answers work, we're going to write out a null set because none of the answers I got for A or X or Y, whatever, doesn't work. That's the only time you want to write that null set, when something doesn't work, when none of your answers you pick works. Let's try another one with the null set. Let's do 33. 33, I have X divided by X minus 5 minus 5 over X minus 5 again equals positive 3. What is my least common denominator? The only denominator I see is X minus 5. So that is my least common denominator. Each part I multiply to X minus 5. Top, bottom, you can cancel. When you cancel, it's all or nothing. So you cancel out the entire X minus 5 on the top and the bottom. Write down what is remaining. I have X minus, I have 5 equal, apply distributive property, 3X minus 15. Before I move forward, what number can X not be? If I plug in 5, what's 5 minus 5? 0. It can't be 5. X cannot be 5. It can be any number I want for X except 5. So if I get that answer, I have to throw it out because it is an extraneous solution. Solve for X. Doesn't matter how you move the X's. Some of y'all have been taught to move all the X's to the left. Some of you have been taught to move the smaller X. However you was taught, do it. It's not a big deal. You're still going to get the same answer for X. I'm going to move the small X. Subtract X on both sides. And then I'm going to move that minus 15 to the right. Now, if you don't like this way, you do it step by step. That way you won't miss it. These go to 0. These go to 0. So hopefully I moved everything the right way. But if I did, it's not a big deal. You can fix it. 15 minus 5 is 10. 3x minus x is 2x. Again, if you don't like me doing the multiple steps, you do it step by step. You're just solving for x. That's it. Divide both sides by 2. X equal 5. We've already said if I plug 5 back in for x, 5 minus 5 equals 0 in my denominator. I don't want that. This is the only answer I have for x. So I have no answer for x. I'm going to use my empty set because I have no answer for x I can use. And I'm going to say that 5 is extraneous. It is a false solution because I do not want an answer that's undefined. And that's how you will write your answer. You will write the null set, 5 is extraneous. That would be your answer. So if we did a multi-test question, I may have something, and let me set it up. If we do a multi-test, a multi-answer question, I may have something like A, B, C, D, and E. I may have 5. I might have -5. I may have a null set. I may have 5 is extraneous. I may have -5 is extraneous. And if you remember from your midterm, you have the little multi-answer little image on your test. So if I say this is a multi-answer, you're going to check this answer, and you're going to also check this answer. We're going to say that it is an empty set and 5 is extraneous. Those are the two answers that you would mark if I gave you a multi-answer question on your test. Very important that you remember that. So you do have to tell me that none of my answers worked and 5 was a false solution. Let's try another one where we don't have a null set, but we do have an answer that is extraneous. Look at 37. I have x minus 4 over x minus 3 plus x minus 2, x minus 3 equal x minus 3. Look at this one. What is my LCD? The only denominators I see is x minus 3. My LCD is x minus 3. I multiply by each part. The parts are separated by the plus sign and the equal sign. So this is one part, two parts, your third part. You have three parts. So each part I multiply by x minus 3. Cancel out. X minus 3 over x minus 3 cancel out to 1. It does again. I have nothing to cancel here. It has to be 1 in the numerator and 1 in the denominator for me to cancel things out. Write down what's remaining. X minus 4 plus sign x minus 2 equal, I do have to FOIL. So you won't mess it up. Put parentheses around that x minus 3 and have to do FOIL method or box method. We talked about both of those strategies in previous notes. First is x squared. Outside is negative 3x. Inside is negative 3x. And last is positive 9. A lot of information, but just put everything together. Tell me how many answers are you going to have for x and how do you know? I see x squared one time. I'm going to have 2 answers for x. And I tell students all the time, move everything so that the leading coefficient stays positive. So I'm going to take everything here and move it to the right because I'm going to have 2 answers for x because my degree was 2. I'm going to do a rewrite. I'm going to say 0 equal. I'm going to write down the x squared, the minus 3x plus 9. Now, I'm going to move x to the right so it becomes minus x. Minus 4 to the right becomes plus. The positive x to the right becomes minus x. And then the minus 2 to the right, so it becomes plus 2. Okay? Next step, combine like terms. I have 0 equals x squared. Combine all like terms you see. Negative 3 minus 3 is negative 6. Negative 6 minus 1, negative 7. Negative 7 minus 1, negative 8. So minus 8x. So 3 plus 1 gave me negative 8. Constant terms, put them together. 9 plus 4 is 13. 13 plus 2 is positive 15. Okay? So make sure you look at that. Make sure you combine your like terms correctly. Type it in or calculate it. Use your mental math and calculate it. Let's keep moving. We have 0 equal. I'm going to have 2 answers for x. I'm going to factor. I have x times x. What will multiply to give me 15 and add to give me 8? 5 times 3 is 15. Negative 5 minus 3 is negative 8 in the middle. Now, this is in factored form. So you take each part and set it equal to 0 and solve for x. X minus 5 equals 0. X minus 3 equals 0. So x equal 5. X equal 3. Now check your work. What can x not be? If I plug in 5, 5 minus 3 is 2. So this one is good. It's not 0. It can't be 0. And then 5, and then plug in 3 for x. 3 minus 3 is 0. I can't use this one. So my answer that I would write, my answer is not an empty set because I do have an answer for x that works. 5 is an answer. I can use 5. So I'm going to say 5. And then I'm going to say 3 is extraneous. So my answer would be 5. 3 is extraneous. So if I did a multi-answer, you will check 5. You will check 3 is extraneous as your second answer choice. So that's an example of 37 where you didn't have a null set. You have a null set if none of your answers work for X. But I had an answer to work for X, so that's an actual answer, 5, because 5 minus 3 is 2, not 0. My denominator cannot be 0. 3, however, equals 0. 3 minus 3 is 0, so I can't use 3. Let's try another one. If you look back at 6.4 notes, we talked about how to find the least common denominator. Every denominator that's different makes the LCD. We're going to look at an example of that again. Let's look at number 39. 39, I have V divided by V plus 2 plus 1 over V minus 1 equals positive 1. Okay. How many different denominators do you see? I see 2 different denominators. Take your time and write it out. My different denominators are V plus 2 and then V minus 1. Write it again. V plus 2 and then V minus 1, and do it one more time. V plus 2 and then V minus 1. Start canceling out. Some of you know how to do it like a butterfly method. You know to multiply the V times the V minus 1 and then the 1 times V plus 1. So if you know how to do it that way, that's fine. But I'm going to do it this way because we can see it better. What is left over? I'm going to write this out this time and then we'll work it out. So I have V times V minus 1 plus 1 times V plus 2 equal, and then we'll FOIL out the right hand side. I'll do the FOIL on the next step. Now let's work it. Distributive property, V times V is V squared. V times 1 is minus V. Plus 1 times itself is itself. FOIL this out. First, V times V, V squared. V times negative 1, negative V. 2 times V, positive 2V. 2 times negative 1, negative 2. How many answers will you have for X? Well, I see that when I subtract V squared, it's going to equal 0. So I'm going to have only one answer for X. It may work, it may not work. We'll have to see when we do the math. But if I look at this, look at 39. What can V not be? 2 minus what is 0? V can't be negative 2. 1 minus 1 equals 0, so V can't be 1. So V cannot be negative 2 because 2 minus 2 is 0. I'm only looking at my denominator, okay, when I do this. And look at your denominator here only. 1 minus 1 equals 0. So V can't be negative 2 and it can't be positive 1. So if I get negative 2 or positive 1 for an answer, I got to throw that answer out because it's an extraneous solution. Solve for V. And I want you to work that out. Get V by itself. Practice. Practice get V by itself. When I solve for V, I should get V equals 4. Now you do the math and you get to V equals 4. Okay? If you cannot get to V equals 4, you got to study. Go back and study your solving equations. Very simple. So, since my answer is V equals 4, and 4 plus 2 is 6, 4 minus 1 is 3. It's not 0. So this is my answer, V equals 4. That answer works. I have no empty set. I have no extraneous solutions. V equals 4 would be the only answer I would mark on my test. That's it. Let's try another one. We got to do a little more work to it. Let's try number 45. It got a lot of information on 45. Let's try this one. 45, I have negative 5 divided by a trinomial. So I already know that when I see that trinomial, I need to automatically think about factoring. Plus 3 over x plus 2 equal 1 over x minus 1. Now, I see binomial, binomial, trinomial. When I see a trinomial, probably have to end up factoring. So let's factor this. What two factors can I multiply to get 2 and subtract to get positive 1? Well, I have s times s is x to the second. I have 2 times 1, which is 2. I have positive 2 minus 1, which is positive 1 in the middle. I'm going to scratch this one out, and I'm going to use this as my new denominator. When you find your LCD, you want to make sure your denominators are written in factored form. This is factored form. I want, if it's in standard form, if it's factorable, factor it out into factored form. So if it's in standard form, write it in factored form. The reason I do this is because now I can see I only have 2 different denominators, which makes my LCD. So everything I'm going to multiply again by s plus 2 times s minus 1. Write it again, s plus 2 times s minus 1. Write it again, s plus 2 times, I'm going to write it under here, x minus 1. It's still horizontal, so this should be horizontal, not vertical. Just saving space. Okay, so what cancels out? X plus 2, x minus 1. X plus 2 cancels out here, and then x minus 1 cancels there. Tell me what's left over. What's left over here? Negative 5 plus. If you can answer the questions, you know what you're doing. If you're struggling with answering the questions, you have to study. Very, very important. You got to study if you cannot answer these questions as we're doing it. Okay, so you got to study. We have 3. Bring down s minus 1 equals 1 times itself is itself again. Looks pretty good. I have negative 5 plus 3s. A positive times a negative makes a negative. 3 times 1 is 3. This is distributive property. Okay, equals x plus 2. You are to solve for x, so we have to be very comfortable with getting s by itself. I'm going to move some things around. I have 3s. If I move positive x to the left, it becomes minus s. Bring down that 2. If I move minus 5 to the right, it becomes plus 5. If I move minus 3 to the right, it becomes plus 3. You don't have to do it the way I do it. Do it however you know how to do it, as long as you get the answer correct. You can go ahead and combine this and make minus a, and then it becomes over here, becomes plus a, or just move it and then put it all together. Doesn't matter, still gonna get the same answer. So 3s minus 1s is 2s. 2 plus 5 is 7, plus 3 is 10. Divide both sides by 2. So s equals 5. Can I use 5? Check it. 5 plus 2 is 7, not 0. 5 minus 1 is 4, not 0. I can use 5. Same problem. I can use 5. So my answer is only s equals 5. That's my answer. No extraneous solutions, no empty set. I do have an answer. S equals 5. All right, let's try one. It's a little tricky, but let's try it anyway. I want to look at number 73. It says solve the formula. This is an actual formula if you're going into electrical engineering. And talk about Ohm's law, resistance. currents, circuits, all that. This is an actual formula. This formula is a little tricky because this is a literal equation. If you took Math 098, you talked about literal equations in that class. So in Math 098, you talked about literal equations. Literal equations are equations with a bunch of letters in it. Mostly formulas that you see in real life application problems, banking, engineering, nursing. You see different types of formulas you have to use. Those are literal equations. Physics, if you took physics, those are literal equations. They're just a bunch of letters in an equation. But this literal equation tells me to get R1 by itself. This one's very different. I see a lot of R's, but this is the first twin, well, the first triplet, second triplet, third triplet. They triplets, but they all got their own name. So all these R's are different people. So I have 3 different denominators. So my LCD is the 3 different denominators. I'm going to multiply by R, R1, R2. Do it again. Do it a third time. Okay. Our goal is to find R1. Now, cancel out like you've been doing. Just the regular R cancel. The R1 go away. R2 go away. Write down what is remaining. In the first part, I have R1, R2, understood to be positive 1, equal R, R2, understood to be positive 1, plus R, R1, understood to be positive 1 there. So do not write the 1 because understood to be a positive 1 as your coefficient. I'm trying to solve for R1. I see R1 2 places. Get them to one side of the equation. I'm going to take this one, or R1, and move it to the left. So I have R1, R2, the additive inverse, minus R, R1, equal R, R2. What's my greatest common factor here? They both have an R1 in common. I pulled out R1, R2 is left over, minus left over, R is left over, equal R, R2. How do I get R1 by itself? Now, how do I undo times? Multiplicative inverse, divide by R2 minus R, R2 minus R. These go away. What is my final answer? R1 equals R, R2 over R2 minus R.